So it's just a mission to go to Mars, and so you can buy some ticket and go there. So you can discover how is this planet. It's a kind of game, you know. It's quite good. If you know, if you go to see some details about this, but in my view, I tried to do this. I bought a ticket to go there. So it was very, very cool. So I'm one of the 20% who had been selected to go in Mars in, I think it's in 2025. I will go there. So it will be a very pleasure. So, but I have just seen last week that I have little problems. That it's just a one-way trip. So, can you close, please? Thank you. So I don't know you, but in my case, I like the life. I just don't want to dead. So I start to see how can I come back by myself. And as I'm a geek and I like doing like the previous talk to create my own robot or my own thing, I have a look about the PolarSys working group, which is inside Eclipse, to create embedded system and to see if I can succeed to create a shuttle, to create everything I need to come back from Mars. And don't know if you heard about PolarSys. There are plenty of technology inside PolarSys, and I will not explain you these technologies. So if you are here to understand how does it work, it's a wrong talk, you can go out, it's not a problem for me. I will just explain you lots of use cases in my own needs to create my shuttle, and how other industrials create this kind of thing with these technologies. So first, I need to create the shuttle itself. So I have a look with one of the two companies we created a shuttle and satellite, NASA, this one, and the European Space Agency. And the European Space Agency already used PolarSys to create this kind of thing, and as they have plenty of different satellites, they need to manage the hardware variability, because I don't know when I will create my own systems, which kind of hardware I have to use. And the one I will choose now will not be the same in 10 years, so I need the same thing. What they do, I will not explain all this schema, but it's just some parts. For example, the hardware part, and they create designers when they describe each CPU, each memory, which CPU will use which memory, what is the speed of the CPU, etc. So all the physical aspect of the architectures. And after this, they describe the components used, so everything which is related to the middleware and the communication between their systems. And for them, they also create some designer to say that this function will be allocated on this hardware. And thanks to this, several use. They use also some data type, and they create code generators to automatize the creation of the embedded code at 100% for all the communication and all the middleware stuff. And thanks to this, they succeed to change just the hardware to go to 8-byte to 18-byte microcontrollers, and they just change the template of the code generators, so regenerate, and it was very more fluent to manage the reliability of their systems. And so they keep the business logic, the algorithm across different generations of hardware. So I can imagine that I have a first step of create the hardware of my satellite. After, I need to simulate it. And I need, when you create an industrial systems, simulation is really something which is just important, because it's not when I will be in the shuttle that I have to check that everything works. So the first, here we are in Toulouse, we are in the capital of Airbus. So I will just have a look at Airbus, how do they do. And they do the Iron Bird aircraft, which is an hybrid of real system and simulate systems. And so they do co-simulations. It was just too complex to just imagine what they have to do, so I just select one use case, which is how they manage the door systems, which is something which is really safety, because you don't want to that it's open at the bad time. So it's in Dutch, so for every Dutch person it's perfect. So it's a door. If it's the first time you see a doors, you will enjoy. And sorry?
It's German, not Dutch.
Oh, sorry. I just speak English, I try to. So, just to create this door, it's very, very, very complex. And for this, they use plenty of different tools to simulate some part. And of course, each tool doesn't know the other. So they do what they call co-simulations. It's to use some existing tools like Simulink to create functional models and to simulate it. And other tools like ADL, which is focused on the architecture and the real-time architectures. And they transform all this stuff inside another model to do other simulations. So each engineer can do their own simulation, their own design, and they merge together. They use for this a Polychrony method, which now will be contributed at the POP project inside PolarSys. To do all that you can see just before as an open source project inside PolarSys. And so the main result was a validation on different domain and different tools. A second example of simulation has been made by this guy. So, Ortal, which work with CMC, which is a subcontractor of Boeing in Canada. And they do virtual hybrid simulation, in quite the same way than before, but with very, very large models. When we speak about simulation, it's 100 actors, could be 500 models, or very, very large elements. A classical method just doesn't work. So here is the classical V-cycle, but what they do is to add the virtual hybrid testing here, and to create several designers on your own methodology, or own views. And for this, they use Sirius. And they use GenDoc to generate doc for certification, for any kind of thing. And they manage the life cycle with EMF compare. After, they add other hybrid to manage the asset of different versions, dependency between some part of the simulations. And they deploy directly on the simulated engine with 15 PC which work together to do all these kind of simulations. And so the main result that they can create their own simulation chain, and with every part is a module that you can add or not depending on the system. So for my space shuttle, it could be good because I can reuse some parts which are being used by CMC, but other it can be just for me. And everything is integrated thanks to the Eclipse platforms. But as I already said, I don't want to be dead. So I want to just verify that all the security and the safety is in the right way and everything will be under control. I have a look at Alstom. No, in Europe, to create a safety systems, I think they are one of the best company we can imagine. And what they do today is mostly based on Excel, because there are some guy, we read a newspaper to find some accident and to just describe inside Excel what are the consequences, what are the scenarios of the accident. And after, to each generation of the TGV, that train, they see that if all the safety analyses are right or not. But of course, there are two life cycles. And it's complex to manage the version between the two, and a collaboration between the team we create the train and the team we verify the safety. So they try to go further than Excel and to use models to describe their scenarios and to inject inside this some methodology. So what you can see here, for example, the result, SIL2, the result of a level of certification, which is just directly inside the same designers as the designer which helps you to create the safety scenarios. So it's just simple, so more efficient. So this you can also apply an engine to see what are the level of the security of each part of the systems. Everything is based on the methodology of Alstom. Nobody has to explain them how to train. But they can do by themselves all these tools because the Eclipse modeling doesn't bring you some ready-to-use tools, but all the tools you need to create your own. So you can have some view on your systems with the point of view of the safety guy. For example, to say that this function to space the train has this level of certifications. Yes, let's go. Let's continue. With this, I have train use cases, but it's not. I will not go to Alstom to ask them to work for me for a shuttle. It's not their business. So thanks to PolarSys, there are some discussion between end user and providers, and one provider, which is called All4Tech, heard about this story and say, oh, there is a business for us because we do safety, but we do safety across different domains. So they create a product based on their skills and based on this kind of use cases. But this product is now more general and can be usable in any kind of domain, mostly in my case of space transportation. So you can see it's rely on the same technology, which is called again Sirius. It's included inside Eclipse. You can see it's graphically. You can see the fault problems, etc. You can generate some fault tree to see the consequence from one problem. And one of the main results was just the open innovation between end users, suppliers, research, etc. in a way of PolarSys that everybody work together and everybody find a way to have some cash, to have some investment, etc. So now I can go. But with this, I need to master the system itself to see all the architecture of my shuttles. Well, the best use cases I find was created at Thales, where they create this kind of architecture workbench. And I will just use one, which is the entertainment systems. You know, when you buy an Airbus, I don't know how many of you are already buy a plane? No? Yes? Okay, perfect. Give me your card just after. And each time Airbus sell an aircraft, each time the aircraft is different for any kind of thing. The number of shares, the quality of the share, and on the entertainment. Each customer wants a different screen, you know, with HD or not HD, with lots of different things. So if you have to recreate all your system engineering for each plane, it will just be too expensive. So you have to manage a way to describe different scenarios and to evaluate the cost, to evaluate the rise, evaluate the performance, etc., etc. So they create a project which is called Capella. It has been announced as a new PolarSys project, as an open source project, to master all of these different steps of system engineering. So this will be the biggest contribution in system engineering in the world with this project. It will be really something very important. And it's today deployed at worldwide in Thales and for several thousand people. So you can see lots of different designers. And for this, my previous use cases, you can imagine that you can change depending on the number of the share and the quality. If you need one server or several servers to diffuse the content and the video, you can see in red which part is not performance enough, enough good performance. So you can analyze directly in this, and you don't need to go in other tools. You can rely on existing tools like create connectors, but you stay inside your designers to do this. I see a better picture. I'm sorry about the previous one, which is quite bad. But in this other, you see the design, and after I click on the kind of validations, and you see what occurs and where are the problems. So you can do by increment very easily your design. Everything is integrated inside Eclipse, and everything is something interesting is that it's driven by the process. So for each step, you see only the designers and the diagrams which corresponding to the step of the process. The main result was a tool applicable to lots of different domains. And so you reduce the need to create bridge, to create this kind of thing. Now, with all of this, I have my shuttle, it's safety, it simulates, but I have still problems, is that where I need to go, because in the space, the space is quite complex, you have lots of things to do. And again, with Airbus, they define with their technology, some way to describe the different scenario to navigate. And they do this in a common way for the software and for the hardware. So for this, they create what they call Tofu Designer, which is like a component-based design, inspired from UML. And a part which is like SRT, it was for real-time system, which is fast, and which describes the system. So here you have the software, if you have the system, they combine together, they apply code generations with their own rules of code generations, and they generate lots of files, of C files. And everything is embedded directly in the systems. So the main result, that's openness, flexibility, reuse. Everything is okay? So now I just need the stump to go there and to say, okay, now I will go, I know I will come back. But to have the stump, I have a look, and it's just amazing how much documentation you have to write. It's just more complex to write documentation for certification than to write the system itself. So it's just a nightmare. So I am alone to create my shuttles. It's quite a challenge. You are late.
I'm sorry.
So I will restart from the beginning. Sorry. So for the ground segment system in the space industry, they do systems to generate documentation. In this kind of use case, there are more than only one person. So there are 50 persons in different companies. And they use a project which is called GenDoc, which is today, Stefan, is it already online inside Eclipse, or the proposal is online? I think so.
Yes.
Yeah, and the project will be available very, very soon. So you are directly inside Word, inside OpenOffice. You can reuse the certification charter that you have to use, but you change some part to say that, like this, that it's dynamic and it's come from the models. So it's a way you create generators It's quite easy, and they use it with a project which is not inside Eclipse, which is RSA, to prove that it's interoperable with proprietary or external tool. They use Jenkins to generate, do a continuous generation of documentations. And as you can see, they generate lots of documentation, very lots. You can just imagine 100 page with 150 different documents. If I have to write it by hand, it's just a nightmare. And it's, of course, all this documentation is always up to date. So it's something which is with a very good return on investment. So now it's okay. I can go. I will do like this, like that. Hey, wait, I forgot something. Just, do you remember where I go? Mars. And where are they in Mars? Ready? Martians. Yeah. You're late, but you're a follower. Nice. And what should I do if I meet some Martian? The first, there's this Martian I like in these movies. I can this one, like this one, or like this one. So, if I meet the Martian, I would like to explain them the value of humanity. I just select 3 values that you can find inside PolarSys, of course. First one is freedom, sharing, and humanity also, of course. So, Mr. Martian, my first value that I want to explain before you try to attack the Earth will be the freedom. And in the freedom, I will explain you that, for example, at Ericsson, they want to be free. They want to, what they call, control their destiny, because they want to find by themselves how to do things, and they don't want to be, locking inside the volunteer of somebody else. So they use a lot of Eclipse technology already, but when they need future and evolutions, they pay or they do by themselves this evolution, and they don't keep it for themselves. They contribute to the project. So, for example, with TMF, which is a tracing monitoring framework, sorry. Why do you always use 3 letters for Eclipse projects? Please stop it. And so it's a tool to do tracing simulation at the CDT level, so you can see what occurs. But they do this. There are plenty of features that are not good for Ericsson. They just pay one time, and it was contributed inside the official open source project. So if there is something which is not good for them, just modify it directly inside this. So for them, they are not locked under the control of the software editor. We say you have to do like this. And the other contribution could be useful for you for tracing and monitoring. Second example, they are very, very, very large models, some of the biggest models in the world, and they need difference and merge systems. So they also pay to manage very large scale models and to find a way to be able to reuse this open source technology in their way. And another example, graphical comparison chip. And last example with Ericsson is that they want also to use an open source backend for their tickets and their management systems. But in Ericsson, every team is free to choose the good tools. if it's a tool promoted by Ericsson, it's good, but there was a kind of freedom for each teams. And lots of teams say, no, I agree to use the corporate bug systems, Tulip, but I want to stay inside my Eclipse because I don't want to use another tool to go outside, and I usually use Mylin for this. So again, they pay to create inside Mylin new connectors to manage Tulip artifact, Tulip tickets, and it's announced today. Today it's released on an open source, and with these features, you will have for the first time inside Eclipse an agile planner. So you will have everything you need to do a card wall, and everything you move is on the back end. It's synchronized with a web view inside Tulip. And also you can have some management system like burn chart. You can use it with Luna. It's directly inside the discovery UI of Mylin. It's very cool. So they say that open source and PolarSys help them to control their destiny. It's like Star Trek in the world, but it's very concrete for them. They are free of what they want to do. Humanity. It's not exactly a PolarSys use cases because I'm not member of PolarSys, but it's cool. So I want to show you this one. It's just a way to do hybrid physical and virtual design. Let's show you the demo. For this person, we use a designer where we put the map of the building, and the guy describes each part of the building to say where you can go with your share, if there are some stairs or not, and you can describe where is the button, if I can open a light, open a door, etc. So all the things which are connected to the systems are described this. As this is the physical map of the building which is here, it's just very, very, very simple to configure. That's something, just imagine that you can do the same with automotive, with space, any kind of thing. And after, as we have a good humanity at PolarSys, we add this kind of guy just to select with one action, something which open the door, open the light, close the window, etc. And we will save the world with this. So it's simplified the control design. And the last part is sharing. Sharing is the goal is to share investment, to share knowledge, etc. etc. And it's come from the CNES, which already have lots of code generators. And in near than each company, everybody recreates his code generator for UML to Java, UML to C, etc. Everybody reinvents the wheel, and it's just amazing. So, thanks to PolarSys and the way that we discussed together, we decided 1 year ago, I think so, to merge our effort in only one project, which is really not released but published this week, which is called UML Generators. And UML Generators, be careful, it generates code from UML. We think about the name during a very long time. So it generates Java, but it do reverse from Java to UML too. It generates C, and it do reverse too. And you can also generate the real time, and it doesn't do the reverse. But if you want to pay, you can have, or if you want to contribute, it's open. And to simplify it all the generators are here, and something new that it will be shown for the first time today is that when you are RT-SG developers or C developers, you just want to design header, C modules, or real-time component. You just don't care about something else. So we do a prototype of to store everything in UML, but use Sirius to create just a view for C developers. This one is, for example, for TSG. And you can see the different functions that is linked to this port. The color change depending if the port is reactive or passive. You can go inside, see another view, the type of the modules, of the real-time modules that you want to use. Go inside and see the interface. So it's really driven by the method of RTSG, but everything is still stored inside UML. But you don't care about profile, etc. Everything is hide. In this example, we add another file which is not a UML, which is just the configuration of Ethernet. So you can see which link work on which part of the, which network. So it's quite cool to manage different networks. Another example is just a dedicated UML for C developers, where the guy just create C file, headers, declaration, definition. It's just simple. So that's the kind of technology that we propose inside this project. And for the sharing, you see that it's a share across different companies, like Spacebell in Belgium, yeah, CNES here, OBO, CS, and other partners already ask us to contribute other parts. It's something very cool. And so everybody is happy about this. The end user, because how do I say this? The knowledge is centralized inside one place, and the provider too, because to do the applicative jobs, they don't have to recreate their own generators each time. And if I meet also the Martian, okay, I can explain them. How can I explain them? I have to talk with them. So as you always, I find this in an official picture of scientific articles. They use smartphone. So I plan to create a dedicated application and to create my own application to discuss with them. Of course, still again, I find PolarSys use cases. You can find any use cases with PolarSys you can want. In these use cases, you describe Android application. So you say that here is the screen, and you can say that with this start recording step, you have to press a button to rake, etc. Everything is with image, so it's simple to understand. You can discuss with a stakeholder and some business guy. And you can describe something which is just very hard to explain without something graphical and without something also dedicated to Android. For example, check a phone is just something which doesn't exist in any other methods. And of course, you can do something complex. It generates 100% of your applications, or all the UI only. But it's something very, very cool. And this is open source too, but not inside PolarSys. It's use PolarSys to do this. So I can discuss with them. The last thing is I know how to come back. I know how to speak with the guy who lives in Mars. And the last part is how I can leave them. So to leave them, I need a logistic way. For this, I reuse these use cases, which is about the production line, and you can see some track. And let's see the video. Lots of graphical designers, again. It's just before this, they don't generate code with this. It's just to help them to configure. It's what I call domain-driven design. It's you design the domain, but you don't design the software. So it's just easier than a configuration file that only a technical guy can modify. Here, everybody can modify this. And after you design your configuration of your building, there is an existing engine. We take this configuration, these models, and we drive all the robots you need to manage all this kind of thing. It's cool. So it's Eclipse based. Yep. So in conclusion, with PolarSys you can have some models, some code, etc. Have several tools to work with them. There are plenty of different tools already existing here. You can, and most of them are here to help you to create your own and to give to your users some dedicated view on this. And just parallel with something which already exists inside the building market. That's what they call the BIM, Building Infrastructure Model, Information Model, sorry. That if you already do some work at home with different subcontractors, you know that they don't discuss together, they don't exchange a good schema, it's just a nightmare. And they resolve it by sharing all the specification, the requirement in only one place, and give some viewpoint for each of the different engineers we need to work on a building. So it helps the communications, and it helps also the computation, because you have something in the same way, you can see the consistency between all these kind of different business. Thank you, I hope you enjoy it.